Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. In class 8th and ninth, the algebraic identities, that is the topic which is taken up. And if you ask some of the students in class 10th, what is a cube plus b cube or what is a plus b whole cube, so many of the students are going to falter. They will not be able to tell you the correct identity. You know why? Because when in class 8th, the teacher teaches these identities like the basic identities a plus b whole square, a minus b whole square, a square minus b square, and then in class 9th a number of different identities come up. The students, they are cramming up these identities without actually understanding how these identities are derived. So if you are smart and if you know the logic behind things, then you are not going to forget these identities in the entire life. Or even if you forget the identity in the exam, you will be smart enough to derive the identity yourself without looking here and there. So friends, in this video, I am going to simplify this long, sustaining problem for so many students in our classrooms. How to remember the algebraic identities without actually having to cram them. Right, friends? So the topic is remembering the algebraic identities, and this also is a part of the ultimate guide to speed maths. I keep on telling the students, this is something which every student should study, and every student who is aspiring to clear like the competitive exams, NTSC, IMO, at school level, and then at college level, at professional level, when they are entering into some kind of quant exams, you need to study that. I'll tell you all the details of that also. Let's first focus on the algebraic identities, the way to remember these algebraic identities. Now, there are some basics which I will tell you first, and then I'll tell you about the book, and then I will tell you how to extend those basics to remember the identities for entire life. So the first basic we should know is the concept of Pascal's triangle. Now, if you know Pascal's triangle, it works out for so many different concepts, and it's a wonderful mathematics concept. For simplicity's sake, I am not going to draw a big Pascal's triangle. It's going to be like starting with a 1, then starting 1, ending 1, starting 1, in the middle 1 plus 1, 2, and then ending 1, then 1, 1 plus 2, 3, 2 plus 1, 3, and then ending in 1. Likewise, you can extend it more, but for me, only this much is also enough if you have to remember all the algebraic identities up to cube, like a plus b whole cube, a minus b whole cube, a cube plus b cube, a cube minus b cube, all those. The first concept of Pascal's triangle. The second concept, whenever you are writing a plus b whole power n, any expansion, maybe n is 2, 3, 4 or any number, okay, the number of terms of any expansion is always 1 more than the exponent. Here we have n, so the number of terms in this expansion will be n plus 1. For example, if I am doing x plus y whole power 5, then because this is 5, the number of terms in this expansion will be 6. That is 1 more than 5. This is the second concept which everybody should know. And the third one, when I write the expansion of x plus y raised to power anything, say 4, I'll start with the 4. I have 5 terms, right? You know the second concept, 4 plus 1 is 5, so 5 terms. Now, what will happen in those 5 terms? There is a sequence. There is a rule which the 5 terms follow. And what are those 5 terms? The first term in the base is x, right? So you will always start with this exponent of x in the first term. So in the first term, you will have x raised to power 4. In the second term, you will have x raised to power 3, reducing by 1, right? In the next term, you will have x raised to power 2. In the next term, you will have x raised to power 1 or simply x. And in the next term, x vanishes. There is no x. So how many terms? 4, 3, 2, 1, 0. 5 terms, and I told you 4 plus 1 is 5. What happens with the second part? Y. You have to go reverse now. In the last term, y raised to power 4. In the one previous to that, you will have y raised to power 3. One previous to that, y raised to power 2. Previous to that, you have y raised to power 1 or simply y. And here, y vanishes. So these are the variable parts. That means the first and the second term in the base, how they are manipulated in the terms of the expansion. Rest of it is very, very easy. If you know the Pascal's triangle, if you know a plus b power n, how many terms are there, and what happens to x and y when you write it in the expanded form. All three concepts done, the base is formed, and we are ready to go into the algebraic identities. Now you will see how easily these algebraic identities will be drawn. And I told you about the speed maths, right? This is a part of speed maths. Here are the title pages, the ultimate guide to speed maths, volume 1 and volume 2. This is ideal for students, aspirants, maths enthusiasts, who love mathematics and who want to explore different things in mathematics. This has short and smart tricks through which you can calculate 10x faster. Very easy language and very easy to understand. Even school students of the age group of 10 years, they can start studying this, and when they pass out of the school, they will be a completely different individual in terms of their mathematical comprehension. And very important for quant exams, especially because this has some video links also, and 2400 plus 1300 practice questions with answer key. Very, very important, that you actually catch hold of a copy of this and keep it in your kitty and use it to upskill yourself, because every student in India and abroad should have a copy of this amazing ultimate guide to speed maths. How to get a copy? There are two ways. One, you can send me a message on WhatsApp, only if you trust online payments and if you trust that you are talking to the right person. This is our official number. I will talk to you directly and tell you the details. 9896369963, that is the WhatsApp number. That's one way of doing it. The second way is, for purchase, you can go to Amazon. So amazon.in, you have the links in the description of this video. You can click the links and book your order for the 2-set combo of the ultimate guide to speed maths. You want to see a copy? I'll just show you a glimpse. Here we have, see, this is volume 1 and this is volume 2, the exact titles which you are seeing here. And if I show you just a glimpse of this, see, you open any page, here we have the magic multiplication tricks, in which we have given the introduction, then we have the illustrations, and if you turn over the pages, you have lots and lots of video links, challenge zones to challenge yourself after every trick, and then for verification, you have all the answers given at the end of the chapter. So amazing thing, and I don't think spending less than the cost of a family dinner, that's the investment we all should do, right, friends? So let's extend the method now and learn these identities for life. So 3 rules and job done. Let's see a plus b whole square. Now I told you the number of terms is always 1 more than this. So there are 3 terms. We always start with a raised to power this exponent 2. In the next term, only a raised to power 1, and in the next term there is no a. B goes the other way around. B raised to power 2, b raised to power 1, and no b, right? See, there is a pattern in the reverse order in terms of the powers of b. Now come to the Pascal's triangle. So Pascal's triangle 1, 1, 1, 1, 2, 1 and 1, 3, 3, 1. How many terms are there? 1, 2, 3. So I need the row containing 3 terms. 1, 2, 1. These are the coefficients of these terms. 1, I don't need to write 1 as the coefficient, right? 2 and then 1. That's understood. And since we have a plus sign here, we will put all the plus signs, and there you go, we have the identity of a plus b whole square. Do you need cramming for this? And so many in our classrooms, the students are suffering because of faulty, you may call it faulty teaching methods also, because the teachers are not able to develop the concepts. They are giving a list of identities to the students and telling them to cram them up, because and how do you apply those identities? Because when you have a mixed bag of questions, it's very difficult to factorize a particular expression, finding out which identity to use. And that's where the problem is. So let's extend this to a minus b whole square. Now, whenever you have minus sign, you will do the same thing. Power 2 means 3 terms. Start with a square, a and no a, b square, b and no b, then 1 to 1, so 1, 2 and 1. Now, when we have minus sign, there is one extra thing you have to do. The first term, positive. So I don't need to write a plus here. So even if I write a plus, it's okay. But normally we don't do it, right? We don't write the plus sign here. It's not required. Next up, the second term will be negative. So positive, negative, positive. Alternate, you have to put positive and negative signs to get the correct identity. So a minus b whole square is a square minus 2ab plus b square. Likewise, now you must be feeling comfortable. A plus b whole cube. Now this is where most of the students get confused between these two, where to put the negative sign. Now I am going to simplify this also, and you will see how easy it is. So power 3 means 4 terms. A power 3, a power 2, a power 1 and no a. Opposite, b power 3, b power 2, b and no b. And then because it is plus, we have to put all plus, but before that, Pascal's triangle. How many terms? 1, 2, 3, 4. The row containing 4 terms is 1, 3, 3, 1. So you will write them as the coefficients. 1, 3, 3 and 1, and all plus, because there is a plus b whole cube, and there you have the identity. A plus b whole cube is a cube plus 3a square, b plus 3ab square plus b cube. You can actually extend this to get another one. See, a cube plus b cube. I'll write these two together, first and last terms. Between these two terms, you have 3ab as a common factor. So you get a plus b in the bracket, and you must have seen this identity also in the textbooks. So everything is, within a particular identity, you find so many results. Likewise, a minus b whole cube. Start with a cube, a square, a and no a, b cube, b square, b and no b, 1, 3, 3, 1 from the Pascal's triangle, and then plus, minus, plus, minus. That's it. You get the identity. A minus b whole cube is a cube minus 3a square b plus 3ab square minus b cube. And if you want to extend it, a cube minus b cube can be written together, the first and the last, and between these two terms you have minus 3ab, a common factor, giving you a minus b in the bracket. That is the identity which most of the students are getting confused in. Friends, it's not difficult, nothing is difficult. It's about putting up the right way. You got to express it in the right way and present it to the students in such a way that they don't have to cram it up. They know the logic, and in case they forget the identity in the exam, they will derive it themselves just by spending 20-30 seconds. Better than leaving the question, right? So friends, this was the first part of the algebraic identities, and I told you how to remember the basic these identities, algebraic identities, and I'm going to extend this to one more video, and next video I will be taking up the derived identities. From this we can derive a cube plus b cube, a cube minus b cube, a plus b plus c whole square, and so many different derived identities. So look for that second part, and in the meantime you can plan to get that ultimate guide to speed maths. I showed you a glimpse of these two books, and a very important thing if you want to excel in mathematics in future. So do practice this, do watch this 2 times, 3 times, and share the video with all the friends who are struggling in basic maths and struggling to remember the identities, so that they can take benefit out of this. Do subscribe the channel and click the bell shaped icon for getting all the notifications. Do let me know in the comments here, is it working for you? All the best.